All right, let's do one more integral involving a logarithm. So in this case, I see the inside on the top and the bottom are the same inside of the logarithm. It shows up in the denominator. So if you recall, the derivative of the log base b of x, that's the derivative of, I can write it as log of the inside divided by the log of b. And so I end up with the derivative of the log. Log of b is just a constant, so I can kind of pull it out. And then the derivative of log x is just 1 over x. And so why is that important? Well, if you look, the thing that's on the inside is now down in the denominator. And so it's like a function, the log b of x, and it's, part of its derivative, a scalar of its derivative. So once again, like when we use substitution, that's what we're looking for. We're looking for a function and its derivative, or at least a scalar of its derivative. And that's what we have here. Okay, so like the log base 8 of x plus 32. Same idea. If I took the derivative of that, what would I get? Well, I would get 1 over the log of b. b is 8 in this case, times 1 over x. All right, the derivative of x plus 32 is just 1. So if I did the chain rule, I'd chain on a 1. But what I'm saying is I see this down in the denominator, and it's a scalar of the derivative of this. So that means I'm going to use substitution. I'm going to make that substitution be the thing whose derivative I see in the problem. So in this particular one, we're going to let u be the numerator. It's one of the rare times that we actually, when we have a fraction, we let the substitution be the numerator directly. And it's just because of the fact that the derivative of u is 1 over natural log of 8 times 1 over x plus 32. And then, all right, so what do I see here? Again, I see, I'm going to erase all my drawing here. I see dx, I see x plus 32 down in a denominator. So x plus 32 down in the denominator. But I do not see the log of 8. So what I need to do is multiply all this by the natural log of 8. Whatever I do to the left, I do to the right. And now I have log 8 du is equal to 1 over x plus 32 dx. So everything that is here now shows up, and I can make my substitution. All right, log 8 x plus 32, that's just u. Everything else, the fraction, x plus 32, the dx, is just the log of 8 times. All right, now the integral. And actually, I can pull that log of 8 out. But this is 0 and 32. I'm plugging those in to this. So these are x's, right? X equals 0, x equals 32. I'm plugging them in for that x. So 0 plus 32. That's the log of 8, log base 8 of 0 plus 32 is 32. So that's what's going in when I plug in the denominator. All right, and then up top, 32 goes in. 32 plus 32 is 64. This is the log base 8 of 64. All right, now this is where a lot of people struggle with this, is properties of logarithms, because these logs are showing up all over the place. Logarithms are exponents. If you recall, when I say the log base 8 of 64, I'm saying 8 to what power is equal to 64. And so 8 squared is 64. So that log base 8 of 64 is just 2. All right. And then likewise, the log base 8 of 32. What power do I raise 8 to in order to get 32? Well, let's call it n. All right. 32 is not a perfect power of 8. 8 to the first is 8. 8 squared is 64. We pass over 32. But 8 and 32 are both powers of 2. So I can write 8 as 2 cubed to the n power is equal to 32 is 2 to the 5th power. So this is 2 to the 3n, powers to powers we multiply, 2 to the 5th. And so this just becomes the equation 3n to 5, so n equals 5/3. So this denominator, the power that I need to raise 8 to in order to get 32 is 5/3. So I can replace this with the fraction 5/3. All right, and now I can do this problem relatively easy. So the log of 8 comes out, the integral is u squared over 2. I'm plugging in 2. I'm plugging in 5/3 now. All right, u squared, 2 squared is 4. 4 divided by 2 is 2, so this is going to be 2 on the bottom. Minus 5/3 goes in, I get 5 squared is 25. 3 squared is 9. All right, that's over top of a 2, and I'll plug that in. So I'll get the log base 8 of 2 minus 25/9 over 2 is 25/18. All right, and then I can write 2 as 36/18 in order for me to be able to do the math. 36 minus 25 is 11. So the log base 8 times 11/18. Or I can say it's 11 log of 8 over, either one of those is fine for evaluating that integral. If I want to use Desmos to check here, I'm going to do fraction. Then up top, I'm going to write log, L-O-G, underscore. We'll put a base, allow me to put the base in there, so I'll put an 8, come out of the subscript, open a parentheses, x plus 32, okay? Press down, go down the denominator, x plus 32, come out of the denominator, and that's when you're going to put your differential. So there's what I get, and then I got 11 log 8 divided by 18. So 11 natural log, let me do this. Let me do a fraction first. 11 natural log of 8, and then 18 on the bottom. You can see we're getting the same thing. So that's use Desmos to check. All right, use Desmos to check, but definitely be able to do the math. Log of 8 is not a rational number, so Desmos is not going to be able to produce a fraction for you. You'll still need to be able to do this math to be able to get credit on the final exam.